All right, so the first manipulative technique that we want to be able to do with polynomials is nothing more than multiplying them by one another. And that begins with looking at the simple case of multiplying a polynomial, so an expression that has several terms with powers in them, by a monomial, an expression that only has a single term in it. So what's our strategy going to be here? It's actually stated right in the statement of the problem what the property is that we're going to use. The strategy is we're going to distribute multiplication over addition. That has the effect in this example of removing the parentheses that surround 8x plus 7x squared and letting us completely simplify this expression. So what does that look like? First, as usual, what I'd like to do just to remind ourselves what's happening is to locate all operations. Make sure we explicitly know where is multiplication happening here, where is addition and subtraction happening here, where are exponents happening here if there are any. So we'll make those really explicit so we know what we're doing. Once we've located the operations, then it's time to distribute. In other words, what that means is we're going to apply the multiplication which is happening to the entire quantity in parentheses, instead applied to each of the individual additive terms inside the parentheses. Usually this is drawn with a little arrow that you'll probably recognize once we actually do that step. That step will have the effect of removing the parentheses for us. And from there, all we have to do is simplify. We're going to have a couple of multiplication problems to do, which is going to require us to combine powers in the ways that we looked at in the previous set of office hour videos. So combined by adding exponents in this example because we're multiplying powers of x. And once we've done that, if there are any like terms to be added together, then that's what we'll do last. Here again, we're following an order of operations strategy where we do all of the multiplications, and then at the end, if there's any additions or subtractions to do, we'll do those. So here's our strategy. Let's see what it looks like in practice. First of all, and this is a step that you'll probably end up being able to skip once you're gained enough experience with this, is identify in this problem where are the multiplications actually happening. And there is actually 4 of them. We have a multiplication connecting the coefficient of 9 to the x to the 6th. We have the multiplication after x to the 6th and before the set of parentheses. That's actually the most important multiplication in this whole problem. We also have the multiplication that attaches the coefficient of 8 to the x that's on that first term in the parentheses, and which is attaching the 7 to the x squared inside the parentheses. So there's a total of 4 secret multiplication signs in this problem. How about addition? Well, that one's always more obvious. We can't hide addition the way that we can hide multiplication. There's one addition happening, and it's right there inside the parentheses. Now, what are those parentheses doing? This set of parentheses. Well, this set of parentheses is telling us that according to the order of operations, if we were to evaluate or if we were to simplify this expression, the first thing that we would do is go inside those parentheses and worry about the terms that are inside the parentheses. And those terms inside the parentheses are being added together. So unless those parentheses were there, we wouldn't do that addition before we did the multiplication of 9x to the 6th by that stuff on the outside of the parentheses. But because those parentheses are there, their purpose is to group those two terms, 8x plus 7x squared, together. And whatever is happening to that whole expression is happening to the value that that whole expression takes. So in other words, that addition in red right here is happening before the multiplication that's on the outside in purple is going to be happening. So that's the purpose that these parentheses are serving. Another way to think about that is it's an answer to the question, what is it that's actually multiplying this quantity, the quantity 8x plus 7x squared? What is multiplying 8x by plus 7x squared in this example? And the answer is 9x to the 6th is what's multiplying 8x plus 7x squared. So that 9x to the 6th that's on the outside is multiplying the entire polynomial, 8x plus 7x squared. So what does that mean? I'm going to recopy what we have here just to make it a little bit bigger. What that means is we can now use the distributive property of multiplication over addition to distribute the operation of multiplication that's on the outside of those parentheses. Distributing means nothing more than applying that multiplication operation to each of the additive terms that's on the inside of the polynomial quantity. In other words, we're going to multiply the 8x by 9x to the 6th, and we're also going to multiply the 7x squared by the 9x to the 6th. After which we're going to add the results of those two products and simplify. So, and again, I'm going to add in this step here that you are encouraged to add in as long as you're still gaining practice and experience with this technique. I'm going to add in the step where I make that multiplication explicit. 9x to the 6th times 8x plus 9x to the 6th times 7x squared. That makes it clear exactly what we did to get from the first line to the second line here. And now the distribution step is done. In fact, if we wanted to, we could erase those blue parentheses around the 9x to the 6th, because at this point, each of them is connected just to another expression that involves only multiplication. So the associative property of multiplication says that those parentheses are no longer necessary. Now we can simplify using the techniques from the previous videos by rearranging each of the terms so that the coefficients are together and so that the powers of x are together. In the first term, the coefficients 9 and 8 go together, and the powers x to the 6th and x go together. Again, this is a step that I like to write out to make it really obvious what we're doing. If you skip this, then it's not always going to be clear when you look back on your work later what exactly happened. In the second term, our coefficients 9 and 7 multiply together, that those are like factors, and the powers of x are x to the 6th and x to the 2 this time. Now we know what to do. To simplify a product of powers that have a like base, what we need to do is add their exponents according to the arithmetic layer cake. So, remembering that there is a hidden exponent of 1 on top of that plain old x in the first term, x to the 6th multiplied by x to the 1 can instead be rewritten as a single power of x whose exponent is 6 plus 1, x to the 7th. Likewise, in the second term, x to the 6th plus x to the 2, times x to the 2, can be rewritten by adding the exponents in a single power of x, x to the 6th plus 2, or x to the 8th. Having combined those powers of x, now we just have to simplify the products of the coefficients that we have here. 9 times 8, 72. 9 times 7, 63. And we end up with this expression, 72x to the 7th plus 63x to the 8th. And the last question we have to ask ourselves is this as simple as it gets? Could we make this expression any simpler? And the answer in this case is no, because neither of the two terms that we see here, there are two additive terms, the 72x to the 7th and the 63x to the 8th, are not like terms to one another because they have different variable factors. The variable factors are x to the 7th and x to the 8th, respectively. Because the exponents are different, those factors are different, and cannot, therefore, add these two terms and make them any simpler. So, we're done. 72x to the 7th plus 63x to the 8th. Looking back at everything we just did, our entire strategy was to distribute the multiplication that was happening to the quantity in parentheses across the addition inside the parentheses. So, in short, multiplication on the outside of the parentheses distributes over addition inside of the parentheses. When we do that, we end up multiplying these monomial terms involving x's by one another. We multiply 9x to the 6th by 8x, and we also multiply 9x to the 6th by 7x squared. Remembering how to simplify those products of powers of x by adding their exponents lets us simplify the whole thing. Getting in the end, 7 powers of x in the first term because we multiplied 6 and 1, and also 8 powers of x in the second term because we multiplied 6 powers of x and 2 powers of x. And our final expression has two unlike terms in it, 72x to the 7th and 63x to the 8th. Because they're unlike, it means we can't make the final expression that we have here any simpler, and so we're done.